Okay, I am going to show you how to multiply, simplify, and rationalize these two lovely factors. Okay, so we have the fifth root of 8x cubed over y fourth, y to the fourth, times the fifth root of 4x to the fourth divided by y squared. Okay, so the first thing that I would recommend is to rewrite each factor using rational exponents. So I know that's going to be 8 to the 1/5 times x to the 3/5 all over y to the 4/5. There's our first ratio. And that is times 4 to the 1/5 times x to the 4/5 all over y to the 2/5. Okay? So now I get to multiply, or at least put my like factors together. So I'm going to put my 8 to the 1/5 next to my 4 to the 1/5. And then I'm going to have my x to the 3/5 times my x to the 4/5 all over y to the 4/5 times y to the 2/5. So now I can combine my factors. Okay, so that gives me 8 times 4 is 32, so that is 32 to the 1/5. And then I have x to the 7/5 all over y to the 6/5. Okay, now I want to break away any whole exponent, any integer exponents that I can. So, well, first of all, 32 to the 1/5 I know is 2, because 2 to the 5th is 32. So I get 2. And then x to the 7/5 can be rewritten as x to the 5/5 times x to the 2/5. So if we use our mad spin rules and add these together, we get 7/5. So I'm just kind of undoing that. Likewise, y to the 6/5 can be written as y to the 5/5 times y to the 1/5. Okay, well, y to the 5/5 is just y, so that's cool. And so I want to rationalize this denominator. So I want to get this 1/5, I want to get that to 5/5. So I actually don't want an equal sign here. Okay, what I want to do is multiply by a special kind of 1. Okay, and what would I add to 1/5 to get 5/5? I would add 4/5. So I'm going to multiply the denominator by y to the 4/5. Again, it's a special kind of 1, so that means if the denominator is y to the 4/5, the numerator has to be the same. So we're actually multiplying the ratio by 1. Okay, well, now I can simplify that over here. So I have 2, and then x to the 5/5 is x to the first, or just x. Okay, then we have x to the 2/5 times y to the 4/5 all over, and y to the 5/5 is just y, and then when we, don't forget, when we multiply y to the 5th times y to the 4/5, again we get y. Okay, so now I'm going to go back and let's simplify this a little bit. So we have 2x, okay, and this is the 5th root of x squared times the 5th root of x to the 4th. I'm sorry, y to the 4th, my bad. And then we have y squared in our denominator. So we have 2x outside the radical, and then x, since these are both the fifth root, I can take x squared times y, and, oops, I lost a 4 there, this should be y to the 4th. Okay, so this is y to the 4th here. And then this is the fifth root of this, the fifth root of x squared y to the 4th. And that is all over y squared. And that, my friends, is the simplified quote-unquote version. I don't know how simpler it is, but the denominator is rationalized, and the professor that assigned this problem should be happy. Just saying.